This video will be an introduction to catchments and land use areas and how they are used inside of Open Roads Designer, drainage and utilities. I'll also be going over the symbologies that make up these two different feature definitions. The tools to place catchments and land use areas are going to be found on the Layout tab here and here. And I'll start with catchments. I'm going to place an asphalt, concrete, and roof catchment. So when we're placing one of these single area catchments, if I take a look at the properties, this area is going to be defined by a single area with a single runoff coefficient. This type of catchment feature definition is good for when you have just one land use that you're covering. Next, I want to talk a little bit about the land uses. So I'm going to draw in two land uses, one shape for asphalt, concrete, and roof, and then one for pasture rolling. So I'll start by placing a land use for the pasture. This is only going to draw in 2D when we're doing the land uses. And then next I'll do an area that's going to be defined by asphalt. These are not catchments, so these are not drainage areas that you're going to be assigning an outflow element to. These are purely shapes that are going to find different land uses. So if I take a look at the utility properties, or the drainage properties, I have a rational C value assigned for the asphalt, and the same is true for the pasture. So when you're using land uses, you're going to be using the catchment land use. And it's the catchments that are going to be drawn in the 3D model. So if I take a look at the properties of this catchment now, the properties for this feature definition land use, instead of having a single rational value, I'm saying that the area is going to be defined by land cover areas. So I'm going to go to the Analysis tab and compute the hydrology with that catchment selected. Once that's complete, I'm going to see the weighted runoff coefficient at 0.706. So I'm going to take a look at those two collections. And it found the area of the asphalt that fits inside of that catchment, 3.69 acres, and then also the area of pasture that fits inside that catchment. And with these different values, it's going to compute the weighted runoff coefficient. Let's take a look at a catchment feature definition to see what type of symbologies make that up. So we're going to have a center feature symbology, which is going to control how the element looks in plan view. It's also going to control what we're seeing over here in the 3D model. And then in addition to that, we do have a surface feature symbology, which is also going to affect what we see in the 3D model. So let's take a look at those two different symbologies. Right, so for the land use linear symbology, we're going to have a default element template, which I have pointing to a plan element template, which is going to give me the line work you see here in white. And then the 3D element template is going to give me this solid over here in 3D. So I will place one more catchment. This time I'm going to choose a different feature definition. We'll go back to the asphalt. You can see this one is still going to be on the same level. So this is drain area, and this is also P drain area, but they're two different colors. So this is how we're achieving this, is through the symbology. And we're also pointing to this 3D element template inside of the surface feature symbology. And we're doing that for all of the different drainage area feature definitions.